मैच नहीं है नहीं है रजनी मम्मी को सपना आया कि आज उसका एक्सीडेंट हुआ इसलिए वो साइकिल से नहीं आया क्या हाँ क्या क्या मतलब कुछ भी लॉजिक है बताऊं उसको उसे बताने से नहीं आती है तो बताओ नहीं क्यों मैं क्या
क्या बड़ा
जी आया
बहुत क्लासेस के बाहर आ रहा है ये मेरे ख्याल से वो सेमिनार अटेंड किया उसका फर्स्ट टाइम देगा फर्स्ट टाइम यू आल्सो एग्जाम्स क्या पढ़ रहे थे लोग आई थिंक यू अटेंडेड लास्ट क्लास यस क्या
चलो इंफ्रास्ट्रक्चर
अच्छा
completed sound.
Okay. What is remaining now?
Now we have to start at market is also
So we are left with only two chapters: current, electricity, and magnetism.
yes sir.
Okay.
So current magnetism
पहले current electricity क्योंकि वो heavy topic है पहले वो करेंगे फिर magnetism. So what is the status? We have to start.
yes
Where are others? Are we expecting others also to join? They have exams.
Mitchell will come
Only. And what about others? Why? Exam.
exam got to
Huh? Probably exam. Okay. Okay, so we So the last lecture we had was on 13th December. We have already started current electricity. We already started current electricity.
no sir
Yes.
no
Where is your notebook? Check your notebooks.
so last was in sound only
Which you attended, but the other people who attended they started current electricity. You weren't there, yeah. That's maybe the thing. Okay. ठीक है, चलो current electricity करते हैं. Okay, so this is chapter number 9. So first topic is sources of current. So first let us understand types of current. Types of current. So do you have any idea how many types of current you are familiar with? Which are?
direct and
So one is direct current. Which is also called as
DC
DC. Right. Second is alternating current. called AC. What is the difference between AC and DC?
AC flows constantly.
In one direction.
Constant.
So direct current has constant magnitude and it flows in one direction. Whereas AC has changing magnitude, continuously changing magnitude, and it flows in both directions. So if you represent them graphically, this is I versus T, time. I in ampere, time in second. So AC current graph will be like this. It will have a constant magnitude and it flows in same direction. DC current has constant magnitude and flows in same direction. Okay, whereas AC current graph is like this. So AC current is like this. Okay. So AC current is represented as small I and it has both positive and negative direction. And its magnitude also varies continuously. Okay. So this is.
So the negative is its displacement.
It's not displacement, it is current here. See, in case of mechanics, in motion, what changes with time is displacement. The position changes. Here, what changes with time is current.
So it is increasing.
So
and decreasing.
current is displacing, changing. Displacement is for change. So the variable here is current in this case.
But then ampere cannot be negative.
Direction is not negative. In the sense of physical direction, current. But here, one way it goes like this, the other way it goes like this. So this is the change of direction. Okay. Not in the sense of vector. It's not a vector quantity. Okay. So that way. So this is time in second, time in second. So AC current is represented as small I. Right. Now we have to start with AC current. AC alternating current. Its magnitude and direction. Changes periodically. Okay, that's AC. So we are going to learn only about this, the first one, DC in this chapter. Okay. So the first topic is sources of DC. That's what we are going to know. Its magnitude. Okay. So can you give me example of AC and DC current?
DC is found in batteries
Cells. Okay, a toy which is operated by a cell operates on DC current. The mobile is the best example. Everyday use. What do we run it on? Battery. Okay, battery. And so sources of DC is cell or battery. What's the difference between them?
Battery recharge data.
Cell is one cell and battery.
Cell is single. So cell symbol is this. This is the symbol of cell. So what it consists of, I will tell you quickly. And battery is combination of cells. So batteries are combination of two or more cells. So we are talking about electric cell, okay? So you must have studied about, so this is the source of DC current, okay? Source of DC, but in common language we say DC current. Actually DC itself means direct current, but we say DC current, AC current, okay? Now, so what is the cell made up of? Cell structure. Cell is made up of electrodes which are dipped in electrolyte. This is a cell structure. Okay. So these are called electrodes. So what are these? Positive and negative? These are electrodes. So generally they are like copper, zinc,
Electrode taking.
and electrolyte is some diluted acid. Listen carefully, then ask question later on. So this is your electrolyte. You must have studied it in chemistry, I don't know.
Yes.
So this is diluted acid. H2SO4 mixed with water will produce aqueous or dilute acid. So what is the property of dilute acid? It will dissociate hydrogen molecule and sulfate molecule as ions. Okay? So diluted acid will have H2 plus plus and SO4 minus minus ions, right? And when electrode is dipped in electrolyte like this, now this has deficiency of 2 electrons. And copper as a material has tendency to donate electron easily. So it will donate 2 electron to S2 plus plus. Okay, so when 2 electrons go here, so this will develop positive charge. Okay, and this will come out as hydrogen gas. Right? So copper electrode reacts with the electrolyte, produces hydrogen gas. Okay, and in that chemical reaction, it becomes positively charged. Likewise, SO4 will react with zinc and it gets deposited on zinc, so it will deposit 2 additional electrons here. So now the other electrode is becoming negatively charged, right? So this chemical reaction will go on for some time till it achieves equilibrium state. Okay, so now what has happened? These electrodes have become positively charged. One has become excess with negative charges and the other is deficient of negative charges, which is called positive charge. Positive charge is nothing but deficiency of electron. Initially, both had equal number of positive negatives, so they were having no net charge.
So copper is positive because you attach the positive battery to it.
No. Right now, how this cell is made, I am teaching you that. Why one of the electrode of the cell has got positive charge? It's because of this.
But if you reverse the current, then zinc can also be positive, right?
If the what?
If you reverse the flow.
No. It will become neutral. The charges which it has lost, it will get it again. So first you understand what is cell structure. Okay, every cell will have these three components: two electrodes and an electrolyte. Understood? So the cell that you get in market, so the most familiar cell you must have seen is this. Ever ready, right? So what it has is, this thing is electrode. So basically it is this. Okay, this thing is electrode which is positively charged. So this is positive charge. Okay. And the container outside, this is another electrode. So how it got positive charge? Because there is an electrolyte which is built inside. What do you have is electrolyte.
Battery acid is always sulfuric acid.
No. We'll come to it. First, you understand one. There are various combinations possible. You may choose electrodes made up of different metal, lead, etc. Then you can have some different acid. Okay. So those combinations are possible. So this is the most familiar cell that you are familiar with, right? And there is this covering. So this is an insulator outside. So now here, what kind of charge is developed on? So this is positive terminal, and all the negative charges are developed here on this. So this is your negative terminal. So whenever you buy a cell from market, you will see it will be marked above positive here somewhere and down negative. So now you connect a wire over here. This is how, okay, the circuit is made. Bulb is connected and you can operate it with the help of a switch. So when you press the switch, then the current begins to flow. What is the current flowing process? Now look here. So now,
So the negative electrodes are the boundary of the cell. In that
yes,
case,
the casing. The casing is also metallic. Okay, this is one electrode. The casing is another electrode, and in between what is built is electrolyte. Correct?
completely harmful to touch.
Obviously, touch, eat, come in contact, but generally it is safe not to consume. By touching external, it's fine, but not too much. Don't start using it like an ointment. Okay. So accidental touching, just wash it off. It's fine. All right. Now let's see how this current, how the cell is supplying current. We said, what is the source of DC? Cell. Now inside the cell, once the charge separation has taken place, okay. So now if you put any electron, let us say, so that electron will be, let's say I put an extra electron here. How can I put an electron? I connect some load like this. What is the load? Any external appliance, like in this case it is bulb. When I close the switch, this is the switch. So what is conductor? Conductor is also a copper wire outside the cell. Conductor has free electrons, right? Conductor has its own atom and free electrons in this. So this electron, right? This is positively charged and it has electron everywhere, right? Everywhere it has electron. Yeah. Everywhere the electrons are there inside conductor also, right? So this electron will be put, this electron will go here and neutralize this positive charge. This also will neutralize. Then what will happen? This will supply 2 more electrons, right? Now the equilibrium condition is disturbed. So it will again, so when will it reach equilibrium? It will reach equilibrium. So H2++ answer here. Now when it tries to go and react with CO, it has enough positive charge to repel it now. That is the equilibrium condition. When there is sufficient positive charge and sufficient negative charge, the reaction will stop. It will build some amount of charge, let's say 10 positive and 10 negative. That is the equilibrium condition. So it will always maintain 10 positive and 10 negative. Whenever that equilibrium is disturbed, because now this charge flew from here.
Flow will be there.
Huh?
If if it is disturbed, then flow of
Then the reaction will start again because it is waiting to react. There are positive charge and negative charge concentration in the electrolyte. So as long as the electrolyte has these charges, the battery will keep on supplying current. Because these charges are neutralizing also, no? The charge creation is happening via chemical reaction. And charge neutralization is happening when the current flows. Okay? So it will keep on supplying extra charges as long as the electrolyte has reacting ability. So there are two things. One is equilibrium condition. These are advanced topics not mentioned in the book, but I thought I'll let you know so that you understand the process. Okay? So equilibrium condition is when the opposite charges are developed on both the electrodes. That is equilibrium condition. Once the opposite charges are developed, cell is ready for use. Cell is ready to supply current. Okay? So one is equilibrium condition. So these are the two things, two aspects of chemical reaction. Like it's not like chemical reaction will go on forever. Right? Any chemical reaction, any process that starts, it does not go on forever. Okay? It will strike a balance and then it will remain in that condition. Again, some activity will take place when the equilibrium condition is disturbed. The natural state is equilibrium condition. Okay. Now the equilibrium is disturbed when you start drawing current from the cell. When you switch it on, current will be drawn now through the conductor. So current is nothing but, how we define current is rate of flow of charge through the conductor is defined as charge flowing per unit time through the conductor. And what is charge made up of? It is made up of electrons. So let's say I make a magnified view of the conductor. Okay. And here the cell is connected like this. So what conductor consists of? It has positive ion. The atom will be like this. And the valence electron, the electron in the outermost shell. Since that is loosely bonded with the atom, under the influence of cell, okay, opposite, so this will be pulled, right? So once this electron from the conductor is pulled, one electron will be supplied by this. And this process goes on. So what is it? Till when you can draw the current? Till the lifetime of chemical reaction. Means as long as this chemical reaction between electrolyte and electrode will take place, cell will be able to supply current. This is the process. So when it has lost all its charges, then after the last charge was neutralized, it is not capable of supplying further charges. That's the time to throw the cell and replace it by a new cell. Understood? So what is happening? When the current is drawn from the cell, what is current? Flow of charges per unit time. Where you can define the flow of charges through the cross section, like how many electrons are flowing. So let us say charge is Q. This charge is made up of not one electron, there may be so many charges. So let's say Q charge is flowing in time t, Q charge is flowed, and this is consisting of n electrons. So the charge on one electron is given as E. Okay? How much is the charge on the electron?
1.602.
Yes. So it is n into 1.6 into 10 raised to minus 19 coulomb. And this is also minus, but why are we writing plus? Because although the electrons are flowing in this direction, from negative to positive terminal, but the current direction we assume is opposite, conventional, opposite to the electron flow. I will tell you. Hang on. First, you understand what is this. So this is called conventional current. Okay. So it is taken as opposite to the direction of flow of electron. Electron flow is in this direction, and it is shown like this. But whatever current direction is shown in the circuit is always conventional current. What is I? I is conventional current. So conventional current I. So by convention, okay, it's because in real life, all the phenomena, the flow takes place from higher level to lower level, always. Like water flows from higher level to lower level. If you drop an object, if you drop here, it will not go, it will not start going up, it goes down. So from higher potential energy, it will go to lower potential energy. So natural phenomena are like that. If you place two bodies at different temperatures in contact, the heat flow will be from body at higher temperature to the body at lower temperature. So all natural phenomena take place, the flow takes place from higher to lower level, right? But in this case, what is happening? Electron is going. So the negative charge is called low potential. What is it called? Low potential, low electric potential. And this is called high electric potential, high potential. So there is potential difference, high and low. But how the charges are going from low to high? In case of electricity, what is the flow of charge? From low to high. To make electricity, branch of electricity consistent with other branches of physics, right? So motion may, it is always from higher to lower level. So we devise a concept of conventional current, which we say it flows from positive to negative, meaning high potential to low potential. It is just a concept. Okay, so which makes our learning easy actually, nothing else, just a convention. Okay, to make it consistent with other physical phenomena. Is that clear? So the current is because of flow of electrons, but we say that current is going from high to low, not low to high. Is that clear? Now this is the topic of the next unit, unit B. But now this is all about current electricity. This is the concept. If you get this concept, everything is fine. Okay? Now, depending upon the types of electrode material we choose and the electrolyte we choose, we've got different types of cells. And also, the reaction is also of two types, irreversible and reversible. Okay? Meaning, if I take two reactant, react it, now I get a product. Now from the product, I can cause a reaction so that I get the reactant back. So when the reaction can take place in both directions, that is called reversible reaction. When the reaction can take place only in one direction, that is called irreversible. So the cells that are use and throw, what is the reaction? Irreversible. And the one which can be recharged, recharged and reused are based on reversible reaction. So it depends on the what kind of electrolyte and materials you have chosen. Is that clear? Now you will understand what is given next. Unless you know this basis, you cannot understand what is given ahead. So much gaps are there. So I want you to draw all this. These are concept diagram. Take your notes. Ask me questions. Get this thing cleared first. So current is rate of flow of charge through the cross section. Okay, that's it. So electric current is the rate of flow of charge. Charge is basically electron. Flow of charges, you can say charges. So each electron carry a charge which I mentioned. How much is that? 1.6 into 10 raised to minus 19 coulomb. N is the number of electrons. So half an electron cannot flow. It will be either 1 or 2 or 3, but not 1.5. So this count is integer. So it will be plus minus. Okay. Well, and there are why plus? Because in metallic conductor, the only charge which flows is electron. But in electrolyte, both type of charges are able to flow, both positive and negative. Understand? So in solid conductor, only electron is the charge carrier. But in liquid conductor, electrolyte is example of liquid conductor. Both charges can flow. Okay? So positive charge, the charge is plus E, and electron, the charge is minus E.
Both charges will flow to the positive will get ion.
Huh?
So how can both charges flow at this?
So both are flowing. Current is because of both. So now the concept of current direction. The direction of current is taken as the direction of the positive charge. So let us say positive charge is flowing in this direction. Okay? And the negative charge is flowing in this direction. Let us say. Which will happen when you use the cell. When you start using the cell, then what happens? Let us say this current is flowing. So what is the current direction now?
So
what is the current direction? Listen. This is how it will be. This is how the path will be completed through the cell. So what is the conventional current direction? Like this. So positive charge is going in this direction, and negative charge is going in this direction. But still we are taking current as this. So here the current will be added due to both positive and negative. Understood? Negative is flowing in this direction, positive is flowing in this direction. That is how this.
I get sir how it is working, but what is positive charge? Because negative
H2 plus
charge,
plus.
the hydrogen ions.
Yeah. It is only in the air. The moment it comes here, then it is electron. Inside the conductor, it is electron. It's only in the liquid. Yes, positive, negative. So this, then what about this positive charge? These are fixed ions. What is it? Fixed ions. In solid, the positive charge is immobile. It remains at its place. But it vibrates. If the temperature increases, it will vibrate more. Okay? These are called fixed positive ions. So these basics needs to be very, very clear. Only then you will understand. So once the state of conductor changes, the nature of charge which is carrying current also changes. So all three types of conductors possible: solid, liquid, and gas. So ionized gas is also a charge. No, ionized gas, anything, even oxygen, anything, any gas can be ionized. Plasma is very hot, very, very hot. The temperature is very high. But you can ionize a gas, like in case of discharge tube. When you fill a gas in a discharge tube and pass current through it, then it gets ionized. That's why it glows. Different funda.
How it is a coin battery?
Huh?
Coin battery.
What coin battery?
Small.
What?
Acha, this what cell? Okay, lithium ion. That is called lithium ion. So there the electrode and electrolytes are different. It's not this. It's semi-solid, like a paste. It's like a jelly or gel. Okay. So many combinations are possible. That's the topic of research. So we are having big research these days in producing batteries which can last for so many hours and can give current for many hours before it gets discharged. That's why we are getting these EVs, electric vehicles today. With a lot of mileage, they can give you with one charge in excess of 300-400 kilometers now in one charge. So if you have two charge battery, you can go to 500 plus. In a day, you cannot drive more than 500-600. Comfortable drive is that. That's it. So you have a main battery and a backup battery. So you're good for a day. And then on the other, you maintain a battery bank, and the cost of the battery is more these days. That's why EVs are very expensive.
And the battery replacing is also very expensive.
Because the whole cost is in battery only. There's nothing else.
So then how does a hybrid work?
Hybrid is a different concept, I think.
It gains the electrical energy from its kinetic
So energy can be converted from one form to other. So you have to have a device, conversion device. One that conversion is strict. Even when you apply brake, the energy loss in heating can be used to recharge your battery. So it's all what kind of mechanism you build. So it's called regenerative. You are applying when you are using the battery. Okay, you are losing energy, but that lost energy cannot be lost. It can be wasted in the form of heat, etc. Use that heat again to recharge the battery. So it's a regenerative design, but you cannot have 100% recovery. Some part will be lost because automobile will heat up, right? And if it is heat up, then it will radiate into atmosphere. That you cannot trap back because that is irreversible process. There is the concept of entropy. Okay, so all the physical processes in the world take place which increases the disorder. So there are rules by nature. So this is how nature is governed. So we have a limitation. Human have a limitation. We cannot go beyond God or Creator. The world has been created that way. See, like what happens when you drop an object on the surface, right? When it collides, it will produce heat, right? So before heat, this was cold, less temperature. Now, if you keep some ice cubes so that the table temperature goes back to its normal before the drop, then will this object when it drop, will it jump up? Will it jump up when you cool the table? No. So this process is allowed by nature, but now when you do the reverse, it's not allowed. Okay, so it's deep, and you are only in ninth. Where to go? If you pursue science, then many things will unfold. So right now it is curiosity. Okay. So are you planning to pursue science? Okay, good. All right. So are we good to go further? Everybody note it down?
Yes.
You do note this down because it is not in the book. Okay, especially this diagram and all the description. But for understanding, it will help you.
Brass cap. So that is a brass cap, right?
Yeah, brass cap, which is also a conductor, right? Brass cap is also a conductor. That's it. So this is not magic. This is not magic. This is principle of nature. Right? So this is chemical reaction. What is happening when the current is drawn from the battery? Chemical energy is converted into electrical energy. Okay, when the current is flowing, that is electrical energy, which is then converted into light and heat when the bulb glows. When the bulb glows, what happens? Chemical to electrical to light and heat. Okay, so energy had come from cosmos. It is gone back to cosmos. The cycle completes. Okay. So types of cells. You have two types of cells, primary and secondary cells. Okay, now let us discuss what are the types of cells. Primary and secondary cells. Secondary cells are also called as accumulator. Yes.
It was nothing like the.
More charge, more number. So that is big, huge batteries, accumulators. So primary cells are use and throw type. Okay, these are based on irreversible reaction. Okay, primary cells are based on irreversible reaction. So they are use and throw type. Why use and throw? Can't be recharged. Okay. So depending upon the material of electrolyte and electrodes, various primary cells are possible, such as you have voltaic cell, then you have Daniel cell, backline, Daniel. These are different types of cell configuration. So you'll find this in laboratory. Okay, in your school labs, you'll find mostly their potential difference will be less than 2 volt. Potential difference.
This one is voltaic cell.
This,
This one is voltaic cell.
no, this is not voltaic. Maybe normal cell it is. I don't know what it is called, right? But this you will find in laboratory.
So they are different
Because
they have different
how they are differentiated,
electrodes.
Electrodes and electrolyte combination. What are the different combination of electrodes and electrolyte? More details are not required. What is the difference and all? So mostly these are the one. And in secondary cell you have lead, acid, and nickel iron. Okay. Nickel iron and alkali. These are two types. And lithium ion. Lithium hydrogen. Lithium hydrogen. Okay. Lithium and hydrogen.
So copper zinc.
What is there? There are endless, so many. What is there?
So many combinations.
So many combinations are there. What is there in your syllabus? I'm restricting to that.
So lead acid is in car battery.
So this kind of a cell is called dry cell.
Lead acid
It is called dry cell. So this may be powdered also, not necessarily. Okay. So nowadays you have dry cell also. Okay. Not nowadays, it's old technology. So now we have leak proof. Earlier we used to have cells and batteries where the electrolyte used to leak out. But now it is sealed completely. Okay? So many things are there. So basically this. So what is this? These are the example of the type of secondary cell, and they are based on reversible reaction. Right? So they can be recharged and reused. Can be recharged and reused. So when you are using the cell, it is giving the current out of the cell, right? When you are charging, you are connecting it to a bigger source. So now the current is given into the cell, so current is nothing but flow of charges. So those charges are now pumped into the electrolyte. So the electrolyte is re-energized. That is what happens in your mobile. When you charge your mobile, what you're doing is basically you are re-energizing the electrolyte of the mobile. So you are increasing its reacting ability again. You are filling it back with charges, which is lost when it was supplying current. Is that okay? Understood? So charging is a reverse process. In charging, the current is fed into the cell. When the cell is used, that time it is getting discharged, meaning it is supplying charge. Discharge means it is losing its charge. Is that clear now? Okay. So discharging is when the cell supplies the current, and charging is the process in which cell receives the current and charges with it. Is that clear? All right. Then what will it depend on? Depend on electrolyte. What type of electrolyte it is? Whether it is obeying reversible reaction or it is obeying only irreversible reaction. Will depend on. Okay. This is it. Now you can read the table yourself and understand the difference for yourself. So which cell is heavy duty? Primary or secondary? Secondary. So primary therefore will provide only small current. It will provide small current, right? So and it will apply both small as well as high, as per need. It can I mean, it has a big range. It can supply small current to large current depending upon what kind of appliance you want to run with it. Okay? So then there is the concept of resistance. Now this is another concept. Hello. Concept of resistance. Now look here. When the current is flowing, what is flowing? Charges. The electrons are flowing. Now, the electrons are, one is electron of the conductor, then the electrons which are supplied by the cell, correct? There are two categories of electrons. One is of the conductor, and then the electron supplied by the cell, right? When these electrons are moving during current flow, the electron does not have a free flow. Okay, what happens? These electrons and these electrons, they collide with the ion, the fixed ion. So their path is written by fixed positive ions. So it will, collide. It will gain some momentum, collide, and again it will be pulled by this. So it is like kind of a drift. So this is resistance.
It is caused by the positive ion.
It is caused by the collisions between the electron and the positive ion, and between electron themselves. Like this electron may collide with the electron as well as the ion. So this is what causes resistance. It's not a free flow, right? So what is resistance? It is the measure of obstruction to the flow of current. What causes it? It is caused due to collision of electrons with other electrons and the fixed positive ions in the conductor. Got it? So this is the cause of resistance. It's not a free flow. So how do we measure resistance? It is measured in ohms. So what is the unit of resistance? It is measured in ohms. This is the SI unit. The symbol is Greek letter omega. And how do you measure the capacity of cell? It is measured as potential difference, V.
Voltage.
Yes. So the difference in potential is measured in volt. So potential difference will come again in the next unit. But unless I explain you here, you can't understand this unit. Okay? So we'll define potential difference later on. So, and what is the current? Unit of current? Ampere. Unit of current is ampere. Unit of charge is? What is unit of charge? Coulomb. C-O-U-L-O-M-B. Unit of charge is Coulomb. Time unit is seconds. Okay. So what is 1 ampere? When 1 coulomb of charge flows in 1 second across the cross section of the conductor. Okay. That's what it is. And we'll define ohm again in the next unit. So right now at the term level, so that all the things that I have given you will help you understand this table. Everything is going to come in this table. Now read this table point by point and see if you have any doubt. So next is direction of current, conventional and electronic. What is the direction of conventional current?
Positive to negative.
Positive to negative or opposite to?
Electronic.
Yes, opposite. And what is the direction of electronic current?
Negative.
Negative to positive outside the cell, not inside. Negative to positive outside the cell. Always remember that. Okay. So this is it. That ampere is a very big unit of current, right? So we have other units. Ampere is a very big unit. So we have milliampere and microampere, right? What is milliampere?
10 to 1 minus 3.
And this is?
10 minus 6.
This is the only thing. Because this is a very large current, 1 ampere. Mostly we have, when you do the experiments in lab, it will be current in this range. Okay, so which is not lethal. This is lethal. Okay?
How much is dangerous for our body?
1 ampere is good, like if you hold it for a long time. If it is too high, gone. Like the local train, it draws current over and over.
Yes.
That is like even from a distance, you can go. That's why you must have seen casualties. Some stupid people, like when they run on the roof of the train, sometimes they get electrocuted. Because the potential difference is in thousands, tens of thousands and lakhs. It's such a big appliance, right? Railways. It carries thousands of passengers and the rack weight, right? So much of energy. So if that much of energy comes into you, what happens? You can't take it. You just surrender. Okay. Let's now learn about what is electric circuit. Okay, and the symbols that are used in electric circuit. Symbols used in circuit diagram. So that's next topic. So what is circuit for us? This is the actual diagram. Okay, this is the actual diagram. But we don't draw diagrams like this. We draw circuit diagram which will appear like this. So let's say I redraw this circuit. So I have this bulb. So is it a good circuit? What is law in this? There is no way to start and stop the current. It is always on only. So we need switch. Okay. So let's say we have so there are different types of mechanism available to start and stop the current. This is called plug key. Okay. This is the cell. So each component, these are called electric components. Key, cell. Then what is this? This is called load. What is it called? Load or appliance. Okay. How? There are three components: bulb, cell, and key. How are they connected? With the help of connecting wires.
So on the key there are two dots that compensate.
So how will you connect?
But then there's types of keys, right? Which need a dot.
So hold on, I mean, just wait. I'm just saying, right now this is the circuit diagram. So what is a circuit? What is electric circuit? It is a closed conducting path. The current should start from this terminal all the way around and it should come back to cell again. Positive to negative. Okay? And then within the cell, negative to positive. Is this clear? So what is a circuit? Electric circuit is a closed, it is a closed path. Let us say I open the switch. Then current will not reach cell. So it is open. It's not a closed circuit, okay? So for current to flow, the circuit has to be closed. Okay? So electric circuit is a closed conducting path consisting of various electrical components. What are the electrical components? Load or appliance. Load or appliance, then how the load will be operated? Cell. Then how it will be started and stopped? Key. Switches or keys. Then you require connecting wires. These are the components. And connecting wires to wire it. Because you have to provide some conducting path to all these components. So that is through wires. Right? Now we can start and stop, but we also need to control. We need to increase or decrease the current, right? Like the fan speed, I want to increase. That means I am giving it more current. So how do you control the current? Through the resistance. There are certain mechanisms. Yes. So you can use something like this. It's called rheostat. Okay. And mechanism to regulate or control current. So this in short is electric circuit.
Sir, in our school they told to put the arrow. On
Yes, it's there.
No, arrow on the resistance and then just normally complete the circuit.
That's okay. There are various ways. So first I've introduced all the components, and then in the next class I'll cover. I mean, we'll elaborate on that. So first you do till here. Shall we continue or you need a break for 5 minutes?
Maybe washroom.
Break, sir.
Okay, let's take a break.